Welcome back, guys. Now, I want to just take a look at the ways that they have identical letters, or want to just take a look at the repetition that they have identical items and see what happens. So, for you to be able to understand how to deal with identical letters, let's just do more example and then you understand it along the way. So, the first example says that in how many different how many different letter words can be formed by the word I if repetition is not allowed? This one was not necessary actually. Okay, so what was going to happen here? Our previous videos that we were doing, when we were arranging any letters, we just have to like ask ourselves how many letters are there, which is three, which is 1, 2, 3 spaces. So how many options do we have to pick? The first one, we have 3 options, and then we're going to be left with 2 and 1. So how many ways can be able to be formed by the word I? And then that's where we multiply this one out. And if you multiply all this one out, you're going to get what? You're going to get 6 ways that can be able to be formed by the word I. So this is the same as 3 factorial, guys. So there is 6 ways that can be able to be formed by the word I. But there is something interesting that is happening here, guys. So let me just first show you the ways that are formed by the word I. So here are the 6 ways that can be able to be formed by the word I. Since these letters are treated as identical, they are treated as different. But if we just take a look at this kind of 6 ways that are formed by the letter I, we can see that there is some ways that are the same here. If you can see this I, and then there is this one. This is the same as this one, and this one is the same as this one. So actually, what is going on here? So here's what is going on. Mathematically, these words are different. These 6 ways that are here are different. But logically, or us as human, when we view these kinds of words, we view them as these 2 are the same, and these 2 are the same, and these 2 are the same. But mathematically, these words are 6. Why do I say so? The reason is this one. The word I, let me just show you, and the word I, too, this one. These 2 words mathematically, they are different. So mathematically, why are they different mathematically? Mathematically, they are different because let's say this one, it was 1E, and this one was the second E. Mathematically, this one is the second E, and then this one is the first one, because they treat letters as different letters, So mathematically, these 2 letters are different. Why? Is because this one starts with E1 and this one starts with E2. But us as human, when we view these 2 words, we view them as the same. So what do? Each and every time when we have letters that repeats, we divide by the number that repeats. What do I mean? Why are we dividing? Is because we may overcount this kind of stuff. Since we're doing counting principle, if like we count this letter I and I as two different words, we are overcounting. Why? Is because you cannot count 2 words that are the same and you say that there are 2 while they are the same. So us as human beings, we see these letters as what? 1 letter. So what do? We divide by the letters that repeats. So we're going to just say 6. How many letters that repeats here? We're going to have what? We're going to have this is only 2 ways that repeats there, and you're going to get what? You're going to get 3 ways that can be able to be formed. So from here on, this one, it was the same as if we written is 3 factorial divided by what? By the number of the letters that repeats. Which are the letters that repeats? Is I. We count how many I's E's are there. We have 2 E's, which is 2 factorial. So guys, this is the same as what? As 3 ways that can be able to be formed. So what I want you to understand when you're dealing with repetition is that you first calculate the number of ways that this kind of the number of letters that can be able to be arranged, and divide by the what? By the repeated letters. You can use this formula so that you can be able to understand the n. Yes, the total number of this kind of stuff, which is the total that can be able to be arranged. And this one is the repetitions that are there. So that's it about the arrangement. So let's just take a look at the different examples so that you can be able to understand this kind of stuff. So consider the word Vanessa here. They say how many different 7-letter words can be made by the name Vanessa. I'm sorry, Vanessa, there's just an example. Don't take it personal. So here, how many letters, how many words can we create by the letter Vanessa? We can see how many letters that are there is 7. You can just say 1, 2, 3, 4, 5, 6, 7, and then we're going to have 7, 6, 5, 4, 3, 2, 1. And this is the same as 7 factorial. Then, but we say that when we have repeated letters, we have to divide by the number that repeats. So here we're going to say 7 factorial divided by the number of the letters that repeats. So the number of the letters that repeats is A and A, which is 2 factorial, and then the 2s, and then we're going to have 2 factorial, and then we're multiplying all this. You're going to get the number of words that can be able to be formed. So if you put this on a calculator, you're going to get 1260, which is 1260 ways that can be able to be formed by the word Vanessa. So what I want you to take away from this video, guys, is that when you're dealing with words that have repetition, you first count the number of words that you have, and then you write 7 factorial and divide by the letters that repeats them. But guys, there is something interesting when we have conditions. Let's say they say we must start with the letter A and end with the letter A. There is something incredible that is happening that is going to confuses you if no one explains it to you. And for that one, we'll carry it on my next video. So see you on my next video. Sharp.